Hello everyone and hello to our shop. We are Group 5 and our team include Phước, Mạnh, Hiếu, Chung and me, Tạo. In today's video, we will present two essential quality management tools, FMEA and POKA YOKE, and how we apply them in the production of automotive equipment and components. We will cover a general introduction to both tools, the key characteristics of FMEA, the features of POKA YOKE, and the relationship between them, and their importance in production management. Alright, let's get started.
Have you ever talked about it? Every second behind the wheel is a silent battle to keep everyone safe. Just one moment of distraction, one unexpected situation can change everything. But what if you had a companion who could alert you and keep you safe? Everything could be different. We developed this display for your car, integrating AI ADAS technology. But can this display ensure absolute safety? We apply two special quality control methods, FMEA and POKA YOKE. And that's what we're bringing here today, our Safe View brand display.
2. Cảnh báo va chạm với người đi bộ. 3. Cảnh báo lệch làn đường. 4. Cảnh báo va chạm phía trước trong đô thị.
And we are calling for $5 million for 30% of share.
FMEA is a method that helps us identify potential faults and prioritize them for quick resolution and improvement. Specifically, in FMEA, failure refers to potential issues that haven't occurred yet but could arise. Most describe how a fault might present itself based on its cause and mechanism. Effect is the impact of the fault that could have on the final product, such as the packaging defect that could cause to crashes and affecting the product. Finally, analysis is the step of assessing risks to prioritize improvement, ensuring optimal product quality. The purpose of FMEA is to help identify and address weakness before faults actually occur, thereby minimizing risk and strengthening the quality control. This is not only enhance the reliability, manufacturing ability, and safety of the product, but also reduce the warranty cost, boost productivity, and increase customer satisfaction. FMEA originated with the US military in the late 1940s for weapon production and was later adopted by NASA for projects like Apollo, as well as aerospace and nuclear sector. In the automotive industry, for pioneer to use FMEA following issue the Pinto model. Afterward, the automotive industry action group standardized FMEA for the auto section, along with SPS, MSA, PPAP, and others. In 2019, the AIAG PDI FMEA Harmonic Project established a unified global foundation for FMEA in the automotive industry.
As for POKA YOKE, also known as mistake proofing, it's a method that helps prevent errors right from the source. Instead of waiting for mistakes to occur and then fixing them, POKA YOKE detects and corrects issues immediately during the production process, ensuring the product is always flawless. The father of this method, Shigeru Shingo, developed it in the 1960s and became the key part of the Toyota system, playing a crucial role in quality assurance under the Kaizen philosophy of continuous improvement. For instance, when workers would sometimes forget to install both springs in the car switch, Shingo created a simple process. Place both springs in the tray. If one spring remains in the tray after the task, the worker immediately notices the mistake and corrects it before the product is completed. This is how POKA YOKE ensures accuracy throughout the production process.
In my research, FMEA is often used when there is a new design, technology, or process. For example, when a factory needs to set up to produce an entirely new product. Additionally, FMEA is applied when moving an existing process to a new location to assess the impact of changing the production environment. When there are technical modifications such as adjustment in dimension or materials in the design, I think FMEA must be reviewed to realize any potential risks. But you know, there are two types of FMEAs: design FMEAs and process FMEAs. FMEA merely serves the design team to ensure that potential errors are predicted and addressed before production through assessment of attributes, shape, tolerance, and interaction between the system. In manufacturing companies, we typically apply FMEAs because when the R&D department sends design, we are the one responsible for processing and fabrication. FMEAs is considered a document for approval to proceed with prototype run or mass production. Therefore, it plays a crucial role in analyzing potential failure mode and finding corrective action, such as using check sheet or automation equipment to ensure quality. So, could you explain in more detail on the step of implement FMEA to ensure that this display meets the quality standards?
To implement FMEA, our team follow a systematic step-by-step process to ensure that no potential risk factors are overlooked during the production of this product. First, we specifically identify the process or product to be analyzed based on the detailed drawing or process diagram. All team members must have a clear understanding of the system structure to ensure no steps are missed. Next, we identify the critical requirements to be met from input to output and create the network connecting the function to support the error analysis. Step there, the team lists on the potential fault that the product or process may encounter. We use brainstorming, interview, and survey to gather diverse options. Then the team evaluates the impact of these faults, considering their effect on the customer or internal operation. The fault are assessed on the severity scale from 1 to 10. At the same time, the team identifies the root cause of the fault, evaluate the frequency of their occurrence on the rating scale, and list the control measures currently in place to prevent them. This evaluation helps us understand the likelihood of detecting fault before the product reaches the customer, which is the particularly crucial factor. Finally, we calculated RPN, risk priority number, by multiplying three factors: severity, SEV, occurrence, OCC, and detection, DET. For which high RPN are prioritized the resolution. First, to minimize the risk, the maximum score of the factor is 10, so the maximum possible RPN is 100. In our system, the optimal RPN is below 2000, and found about the research become the focus of improvement efforts. In POKA YOKE, we have three main kinds: a stop device, help prevent abnormal size, and half the process. For example, a machining machine shows signs of overheating with stop, even though the fault hasn't occurred yet. Alternatively, it detects the fault and stops immediately. For instance, in machining workshop, sensors are applied to detect fault and stop the production line at the point to prevent the production of more defective products. Control device help prevent fault. For example, a machining machine might have a mechanism that prevents the worker hand from touching the dangerous area without stopping the machines, ensuring workplace safety. Alternatively, this device can control the flow. For instance, a faulty part detected by a sensor on the production line will be moved to a fixed position to avoid further processing. Warning device use signals such as visual, auditory, or message alerts to inform the user that the fault occurring. For example, sounding alarm to stop the production line.
So, in your opinion, what steps should a company take to implement POKA YOKE effectively? For example, how can we identify potential faults from the start? And is it always necessary to find the root cause? Or should this approach only be applied to serious faults?
To implement POKA YOKE effectively, we need to follow three main steps. First one, identify potential faults. Identify potential faults that could occur during the production process, service delivery, and customer use. This can be done through process analysis, data analysis, employee interview, customer feedback analysis, and more. Second, investigate the root cause. From the identified causes, conduct a root cause analysis to find effective way to prevent them. And this can be done through methods such as process flow analysis, data collection and analysis, practical testing, the 5 whys analysis, and FMEA, and more. Design and implement POKA YOKE by identifying and creating differences to prevent faults. When we identify difference, we must create that difference based on the form of the product, such as shape, size, weight. For example, a connector is designed to be inserted in only one direction and can only be plugged into a specific socket within the entire system. The sequence of the steps in the process, such as standard steps, potential failure steps, and preventing further steps from being carried out when an error occurs. For example, if an incorrect assembly procedure is followed, the subsequent steps cannot be performed. Check parameters, quantity, component residues, and other parameters such as voltage, current. For example, counting the number of wires made in an assembly, and if the quantity is insufficient, the device will be trigger a signal.
POKA YOKE truly has the advantage of simplicity and low cost, but I'm concerned about its limitations when applied to more complex parts of the product, like our screen. So, if a fault occurs in more complex components, will the POKA YOKE mechanism still be effective?
Indeed, POKA YOKE works best for simple and easily detectable faults. However, in screen manufacturing, where components and processes are more complex, we can still apply POKA YOKE by adjusting and integrating more advanced automated control technologies. For example, with parts that require high precision, such as circuit boards or camera modules, you can integrate sensors or automated inspection system to immediately detect any errors in the assembly or specifications. The challenge here is ensuring that the control system is set up accurately and effectively. This requires additional investment in inspection technology, but in return, it ensures high-quality standards and minimizes the risk of errors throughout the entire screen manufacturing process.
You are very convincing. I have to admit, your solution is both creative and profound. It's not easy to turn POKA YOKE into an effective system with such complex technology. The way you integrate the solution not only minimizes errors, but also optimizes the process. Very impressive.
Thank you, Sharp, for appreciating my solution. Regarding the comparison between FMEA and POKA YOKE, both methods share the goal of preventing error and improve product quality. However, FMEA is an analysis aimed at predicting the potential error, while POKA YOKE is a tool for error prevention. The connection between two methods is very close, as FMEA have identified potential error, which allow us to apply POKA YOKE to prevent these errors before they impact the product. Therefore, we have integrated both methods as tools within our product quality management system.
FMEAs and POKA YOKEs are wonderful tools, I agree, but I'm afraid of the maintenance cost. Can that be a burden to the company?
We have carefully calculated and ensured that the investment cost will be recouped within a year to reduce repair and maintenance costs.
Very well. I believe that applying FMEAs and POKA YOKE show that you are truly investing in quality. This is crucial in the automotive part manufacturing industry. For all the reasons that we mentioned, we are ready to invest to your solution. And now, let's enjoy with you.
why do we need to apply methods like FMEA and POKA YOKE in production? Clearly, defects in products not only affect quality but can also cause accident for workers and dissatisfaction for customers, leading to waste and increased production costs. On the other hand, it's difficult and expensive to find defects through 100% inspection and correcting them at each stage, even more costly. Therefore, they are effective tool for preventing, detecting, and correcting errors, helping to improve quality and reduce production costs. Thank you all for following and listening to today's presentation. I hope the information shared will help us gain a better understanding of these important methods in production. Wishing you all an effective work day and see you again soon.